Alright, so we've simplified expressions with exponents having the same bases. And today we're going to solve exponential equations using the concept of bases that are the same. So let's look at our first example. We notice in this case that we have 8 to the x is equal to 8 to the 15th. Now, pretty obvious that if that's the case, then x has to equal 15. So the moral of the story is, if you have two individual terms on either side of an equation, they have the same base, then the powers must be equal in order for that equation to be true. So in this case over here, if I have 6 to the 2x plus 9 is equal to 6 to the 31st, then it has to be true that 2x plus 9 is equal to 31. So I take and just solve this like a normal linear equation. I have 2x is equal to 22, and then x will equal 11. Now it gets more difficult when we don't have the same base, because now we can't set the exponents equal to each other. However, 9 can be expressed as 3. We can say that 9 is 3 squared. And I could express 3 as 9, but I don't want to say the square root of 9 instead of 3. It's just more difficult. So I usually try to go to the smaller term if possible. So in this case, we have a power to a power. We multiply powers. So we have 3 to the 2x plus 2 is equal to 3 to the 4x plus 5. And now I have the same base, so I set the exponents equal to each other. So I have 2x plus 2 is equal to 4x plus 5. Bring 2x over. Bring the 5 over. And x equals negative 3/2. Similar example here. I know I can go 16 times 2 is 32, but I'd have to multiply 2 to both sides, so I can't do that. I have to find the same base for both of these. So 4 is a base of 16, but 4 is not a base of 32. So let's try 2's. I have 2 to the 4th is 16. And I have 2 to the 5th is 32. Again, power of a power, multiply powers. So I have 2 to the 16 minus 8x is equal to 2 to the 35th plus 5x. Same basis, set the powers equal. 16 minus 8x is equal to 35 plus 5x. Subtract the 35 from this side, I end up with 19. And the negative type, bring the 8 over. I have 13. And I have negative 19/13 as my answer. When we don't have nice natural numbers and have fractions, it makes things a little more difficult. 2 is going to be my base here. I know 4 is equivalent to 2 squared. What power of 2 is 1/2? Well, if you remember, we take the reciprocal using negative exponents, so 2 to the negative 1 is 1/2. And then it's just like any other problem we've done, multiply the powers. We have 2 to the 4x is equal to 2 to the, I'll distribute that, we'll go 2x minus 1. Therefore 4x equals 2x minus 1, and 2x is equal to negative 1, so x equals negative 1/2. Very similar problem here. 25 to the second power is not equal to 125. Granted, I can multiply 25 to get 125, but that's not what we're looking to do. We're looking to rename these in terms of a base to a power. So in this case, I have 5 cubed is 125. That's raised to the 4x. 25 is 1 over 5 squared to the 6 minus 6x, and although we still have bases of 5, I need this in the numerator. So to get that in the numerator, I'm going to take and raise it to a negative 2 power, so I have 5 to the negative 2. That takes a reciprocal to the 6 minus 6x. Therefore 5 to the 12x equals 5 to the 12x minus 12. And in this case, you'll notice that 12x equals 12x minus 12. Therefore 0 equals negative 12, which is an untrue statement. Therefore, there's no solution on this problem. And that's all we've got. Make sure you do your Connect Ed and your summary.